Hello everyone and welcome to another video. This week I've been working on yet another side project of mine, which is this 3D Fractal Explorer you're seeing right now. I made this using JavaScript and WebGL, which is basically like the web version of OpenGL. It runs in the browser and with direct access to the graphics card to generate these images. As you can see, you can move around using WASD and also look around using the mouse. And you can also zoom in on the fractal by just moving towards it, because I've made it so your movement speed scales down as you get closer to the fractal. And that is basically equivalent to scaling the fractal up as you get closer, because whether you are slower or distances are larger, there's not really a difference there. I've also made a small editor for the fractal. So if I zoom out again, the way this works is that if I set scale to 0 for a moment, it's basically just like a cube that is made out of 8 smaller cubes, each scaled down by a factor of 2.14 in this case. And then of course these are just like copies of the original cube, so they are also made of 8 smaller cubes and so on. You can zoom in indefinitely there and would always see a smaller cube. That's how the fractal itself works. And then of course, to make that a little more interesting, these cubes can also be rotated. So if I change the slider here, it also scales down a little bit more. You can see now the cube has been rotated around the z-axis, I think, as that. So that's now slightly shifted, but also the smaller cubes in it have also rotated, and so on. That way you can make the fractals a lot more interesting than if they were just cubes. You can see if I change that, I get all sorts of different patterns there. Actually, not too many different, but that's because we're just working around one axis now. Of course, I can also rotate them in some other direction, and now it gets all messed up. Also if I change the scale towards something really big, then these cubes basically get scaled down a lot each iteration, so they form a disconnected set. But if I change the scale to something smaller, they get scaled down a lot less, and that way grow together and form a continuous structure like this one. That looks interesting. That's how that works. By the way, this is based on a video by the YouTuber at CodeParrot. I think that's how you pronounce him. And there he explains a lot more details about how these fractals are actually rendered and the ray marching technique. And he probably does so a lot better than I could. If you haven't seen that video yet and want to learn more about the rendering process, I would suggest you to watch that video too. Otherwise, if you want to take a look at the source code of this fractal generator, I've uploaded this to GitHub, so you can see how that works there. Just click yourself through the different functions and see how I implemented that. And also, if you just want to play with these fractals a little bit yourself, this editor is also on my GitHub page under this URL here. If you are interested in that, you can also just play with it there without needing to download anything or anything. I've put the links to that in the video description, so check that out if you're interested. And otherwise, I'll just now go into a little more detail about some other functionalities in this renderer. One cool thing I implemented about this is the level of detail effect. So basically the iteration count also depends on the position relative to the camera. And the thought behind that is that if something is so small or so far away that it's smaller than a single pixel, then there's really no need to render it. But when you zoom in on it, of course you still want all the details there to be visible, so then a lot more iterations need to be applied over the fractal. And yeah, so that saves a lot of computations on parts of the fractal that are really far away, but then it still makes it possible to zoom in on something really close without losing any detail. So yeah, that's pretty cool. So in fact, you could zoom in on the fractal infinitely far, theoretically. Sadly, there's a hardware limitation inside the graphics card because the floating point numbers there only have a precision of about 10 to the negative 10, and with all the maths going on here, the fractal starts getting really pixelated at about 10 to the negative 7. So yeah, that's kind of sad, but you can still zoom in pretty far on this, I think. So yeah, I'm also using this level of detail effect to reduce noise in the image, because when there are a lot of really small structures on every pixel, the color can be kind of random, depending on which of the structures are hit with the ray. It's ray matching, you know. So yeah, capping the structure size at about 3 pixels really helps to reduce that noise in the image. So yeah, that can be controlled using this slider over here. And as you can see, the image gets kind of really noisy when that value is small, but also loses a lot of detail when that value is large. So I usually just keep that at around 2 or 4 pixels, because that is still pleasant to look at both when it comes to noise and shape. So another thing I implemented are 2 different types of shadows or shading. The first you might already have seen in the video by CodeParade is ambient occlusion. This basically means that the shading of a pixel depends on how many other structures there are between that pixel and the camera. So for example, if I move something really close to the camera, everything behind it gets darker because the light behind that thing is basically obstructed by this very close object. So that is kind of good at giving a sense of depth and scale, especially in here, for example. But it really fails at delivering any details, so this just looks right without anything to see there. So that's kind of problematic. Then the other kind of shading I implemented, I don't know how it's called, but basically works by measuring the angle between the surface normal and the view direction. So surfaces that are at an angle to the camera appear slightly darker. And yeah, that run is really great at showing all the smaller details, but really fails at giving a sense of depth. So if I go in here, for example, it's all really confusing and hard to see what's going on. And yeah, then to get some shading that points out both big and small details, I basically just combine these 2 values by multiplying them. So that's what you're seeing here, and yeah, I think that works quite well. However, some fractals also look good with just the ambient occlusion, so I've left that here as an option. So yeah, that pretty much covers it all for this week. Yeah, there are still a few things I would like to add to this fractal renderer later on, but yeah, I've just run out of time for now, because I also go on vacation in a few days, so yeah, then this will probably mean that I don't really have time for anything like this for about a month from now. After that, I might do another video on this in the future, but at the moment I'm not also really sure what kind of videos I even want to make on this channel. So yeah, let me know what you think about that in the comments, if you want to see more of this Fractal stuff or just my usual OpenGL game dev vlogs. So yeah, thanks for watching, I guess, and I hope you enjoy your summer holiday. See you in about a month.